Welcome to Science for Sleepy Minds. Tonight, you can imagine a room where the light has turned soft and tinted, as if dusk has gently coloured the air itself. Now, very slowly, let that small change in colour widen into something much larger, until it becomes an entire sky, quietly glowing orange above a distant shoreline. And here comes the gentle surprise, like noticing a detail you did not expect in the dark. Those calm, dark lakes under that orange sky are real, but they are not made of water. They belong to Titan, a moon of Saturn, where the air is thick and the weather moves in slow, patient loops. If you feel curious about how a world can have lakes without water, and how a sky can look like a permanent sunset, you are exactly where you need to be. You do not need to stay awake for all of it. Let your body rest while your mind listens lightly. By the end, you will have a simple, comforting picture of what makes Titan's orange skies and quiet lakes possible, one gentle step at a time. If you're tired, you can let that tiredness be here without trying to fix it. You have nothing to prove tonight. There is no test waiting at the end of these words. If your eyes are already closed, that is perfect. If they are open, they can soften. And if sleep arrives early, you can let it take you the same way a calm tide takes a small boat without effort. Titan is far away, but we do not have to travel there quickly. We will move slowly, like walking along a quiet shoreline at night. Titan is one of Saturn's moons, and it is a moon that behaves a little like a world. It has an atmosphere, which simply means it has a blanket of air around it. It has weather, it has seasons, it has a surface with plains and dunes and lakes, and it has a sky that turns the light into a warm orange haze, as if the whole place is living inside a soft filter. As you listen, remember that this is meant to be restful. You're allowed to forget half of it. You're allowed to remember one image and let the rest drift away. You're allowed to float in and out. Sometimes your mind will catch a phrase and follow it. Other times it will wander somewhere else for a while. Both are fine. If you enjoy this kind of quiet science, you can gently support the channel by liking the video or subscribing. And now we can let that thought go, as if it were a small note placed neatly on a table, and we can return to the calm. Take a slow breath in through your nose, only as deep as comfortable, and then let it go. An easy breath out, like letting out a sigh you did not realize you were holding. You do not have to change anything. You're just noticing what your body already knows how to do. Let your jaw loosen a little, as if the muscles are remembering how to be heavy. Let your shoulders sink, not by forcing them down, but by allowing them to be supported. If your hands are tense, let your fingers rest in whatever shape they want, open or curled. Imagine warm water moving slowly through your arms, not rushing, just spreading a gentle warmth that tells the muscles they can stop holding on. If it helps, picture a quiet night ocean. The water is not dramatic, it is not crashing. It is simply moving in slow waves, repeating, repeating, repeating. And with each wave, the surface smooths itself again. Your thoughts can do the same. A thought rises, then settles. Another rises, then settles. Nothing has to be solved right now. Now, in your mind, we can begin to build our Titan scene. Imagine a shoreline under a sky that looks like a soft lantern behind fabric. The light is dim and amber, not bright, not sharp. The air is hazy like a gentle fog, but it feels calm rather than cold. In the distance there is a lake so still it looks like dark glass. It does not sparkle, it does not shout for attention, it simply holds the sky's colour in a quiet reflection. A slow wind moves across the surface, and you can almost picture the smallest ripple, the kind that travels for a while and then disappears. everything is spacious, the horizon feels wide, and the silence feels large, as if the world has turned its volume down. This is where we begin. Not with equations, not with heavy numbers, just with a scene, a calm orange sky, a dark, quiet lake, and one gentle question that opens the door to the chemistry. What is that orange sky made of, and why does it stay orange? And what are those lakes made of, if not water? To answer those questions in a sleep-friendly way, we will start with the simplest layer. We will meet Titan as a place. We will notice what it feels like there. Then we'll talk about the sky and the tiny floating chemistry that colours it. And later we will return to the lakes and understand how a world can have shorelines shaped by liquids that would be gas here on Earth. For now, just let the scene stay softly lit in your mind, like a gentle picture on the inside of your eyelids. Titan is often called a moon, but it behaves like a small planet. That does not mean it is huge. It means it has its own atmosphere and weather and surface features. It is a place where clouds form and move. It is a place where rain can fall. It is a place where winds can shape dunes. And it is a place where liquids can gather into lakes, quietly pooling in low areas the way water does on Earth. When you imagine Titan, you can think of it as a world that borrowed some familiar patterns from Earth, but remade them with different ingredients. Like a recipe made with new substitutes, still forming something recognizable, but with a different taste and texture. One of Titan's biggest differences is the cold. On Earth, water is lively. It can be liquid in a wide range of everyday temperatures. It flows in rivers and sits in lakes and falls as rain. On Titan, the temperatures are so low that water behaves like rock. Not because water turns into a different substance, but because cold makes the molecules move less. When molecules move less, they have a stronger tendency to stay locked in place. So water becomes hard, like stone. That idea can rest in your mind. On Titan, water is like rock. And if water is like rock, then something else can take water's place as the flowing liquid. This is where Titan becomes quietly strange, in a way that is still comforting, because it is not chaos, it is not randomness, it is a calm, understandable shift, different temperature, different behaviour, same universe, same rules, just expressed in a new way. Another big difference is Titan's air. Titan has a thick atmosphere, which simply means the air around it is dense and substantial, like a heavier blanket. If you have ever stood on a quiet night when fog was rolling in, you might remember how the world felt softened. Sounds can feel muted, distances can feel shorter, edges can feel less sharp. Titan's air has that kind of presence, except it is not water fog. It is a mixture of gases, and it is filled with haze. A thick atmosphere matters because it shapes how heat moves and how weather happens. It also matters because it gives Titan a kind of gentle protection. The surface is not exposed directly to the harshness of space. It is wrapped. And then there is the light. Titan is far from the sun, and sunlight there is faint. On top of that, Titan's haze filters and scatters the light, spreading it and tinting it, so the whole world sits under a dim orange glow. It is not a bright orange, it is more like a soft amber, like the colour of a lamp behind a shade, like the last light of evening that seems to linger. If you find that image soothing, you can keep it, a world that lives in permanent twilight. Now, you might wonder, how do we know any of this? How do we know there are lakes, or haze, or a thick atmosphere? We know because we've sent distant visitors. Spacecraft have flown past Saturn and Titan, carrying instruments that can measure and map. And one mission even sent a lander, a small probe that drifted down through Titan's air and touched the surface. You do not need to remember names or dates tonight. The important feeling is simpler than that. We have had gentle messengers. They did not bring back photographs like a tourist. They brought back clues, patterns, measurements, echoes. And in those echoes, Titan began to reveal itself. Now that you have a calm sense of Titan as a place, we can turn our attention to the orange sky. On Earth, you already know something about orange skies, even if you have never thought of it as science. When the sun is low, the light travels through more air before it reaches you. Along the way, the air and tiny particles scatter the light. Scattering simply means the light gets redirected, like it bumps into small things and changes direction. Some colours scatter more than others, and what remains can make the sky look warm, gold, or orange. You can picture dust in a sunbeam. When light hits those tiny floating bits, the beam becomes visible. The air itself seems to glow. That is scattering in a gentle, everyday form. Titan takes that familiar effect and stretches it across an entire world. Titan's air contains tiny particles that float high above the surface. These particles are like a very fine haze. In science, you might hear the word aerosols, which simply means tiny particles suspended in the air. On Titan, these aerosols are not just dust carried by wind, they are made by chemistry happening high in the atmosphere. And chemistry, in the simplest bedtime wording, is what happens when tiny building blocks of matter meet and rearrange. Titan's atmosphere is mostly nitrogen, which is a common gas. It is also the main gas in Earth's air. Titan's atmosphere also contains methane, which is a simple molecule made of carbon and hydrogen. On Earth, methane is a gas you might hear about in the context of natural gas. On Titan, methane is one of the key ingredients that helps create weather and haze. High up in Titan's atmosphere, sunlight and energetic particles can break molecules apart and let them recombine. This is not a loud process. It is not a fiery explosion. It is more like a slow kitchen of the sky, where ingredients are gently transformed over time. When methane and other molecules are broken and rebuilt, they can form more complex carbon-based molecules. Carbon-based simply means the molecules are built around carbon, like many of the molecules that make up living things on Earth. But on Titan, this does not mean life. It simply means carbon chemistry. Some of these newly made molecules clump together into tiny particles. Those particles spread through the atmosphere and they scatter and absorb light. Over time, Titan grows its famous haze layer after layer like a soft veil. This haze is one reason the sky looks orange. The tiny particles interact with sunlight, changing its colour and making it feel warm and dim. You can think of Titan's haze as a kind of quiet paint in the air. Not thick paint, more like watercolour. It tints everything gently, and haze does more than colour the sky. It also changes how heat moves. Some of the sunlight is reflected away before it reaches the ground, like a thin shade on a window. Some heat is trapped, like a light blanket keeping warmth from escaping too quickly. Titan's haze and atmosphere together create a delicate balance, not too simple, not too harsh. A world that keeps its own quiet temperature story. As you listen, notice how this is not a story of chaos. It is a story of balance, of slow processes repeating, chemistry making particles, particles changing light, light shaping the feel of the world. It can be comforting to realize that even on a distant moon, the universe prefers gentle rules. Now there is another reason Titan's orange sky can feel emotionally warm to us, even though Titan itself is cold. Our brains respond to light. Warm colours often feel safe. Dim light often feels restful. Evening light tells the body that the day is ending. It suggests slowing down. It suggests quiet. Titan's sky carries that colour all the time, not because it is trying to comfort anyone, but because the physics of tiny particles and light happen to create that effect. Still, the feeling is real, a soft orange world. A place designed by chemistry to look like a gentle sunset. And now we can bring back the curiosity gap from the beginning. If the sky is orange because of floating chemistry, why are there lakes beneath it? And why are those lakes not water? To approach the lakes in a way that stays calm, we can start with a familiar image again. Think of a lake you have seen in your own life. Maybe you saw it in daylight, sparkling, or maybe you saw it at night, smooth and dark, reflecting streetlights or moonlight. A lake is not just water in a hole. It is a surface that holds stillness. It is a place where wind writes small messages in ripples. It is a place where the sky seems to come down and rest. On Titan, there are lakes that do the same quiet job. They hold stillness. They reflect dim light. They gather in low places. They have shorelines. They have bays and inlets. They look in some ways comfortingly familiar. But the liquid in Titan's lakes is not water. It is methane and ethane. Ethane is another simple molecule made of carbon and hydrogen, like methane, but a little larger. On Earth, methane and ethane are gases at everyday temperatures. On Titan, the cold changes everything. Cold slows molecules down. When molecules move slower, they're more likely to cling together. That clinging is what allows a substance to become liquid. So on Titan, methane and ethane can exist as liquids, pooling into lakes, just as water does here. If that feels surprising, you can let it be a gentle surprise, like learning that the same song can be played on a different instrument and still be the same melody. The melody is this: temperature shapes what a substance can do. On Earth, water is the flowing liquid that makes lakes. On Titan, water is frozen hard, and methane and ethane take the role of the flowing liquids. The pattern remains, the ingredient changes. Now, you might wonder, why do these liquids stay liquid? Why do they not immediately turn into gas? Two simple factors help: temperature and pressure. Temperature, as we've said, is about how fast molecules move. Titan's surface is cold enough to keep methane and ethane in liquid form. Pressure is the weight of the air above. Titan's thick atmosphere presses down on the surface. That gentle pressure helps keep these molecules from escaping into gas as easily. So the lakes can exist. They can stay. They can breathe in slow cycles of evaporation and rain. And we'll explore that weather cycle later in a calm way, like describing a slow loop. Before that, let's let the lakes take shape in your imagination, softly and clearly. Picture the polar regions of Titan, the areas closer to the top and bottom of the world, like the Earth's poles. Those regions are colder, and in many places on worlds with weather, colder areas are where liquids and ices like to settle. On Titan, the polar regions are where many of the lakes are found. You can imagine them like cool corners of a room where little condensation gathers. Not dramatic, just a natural tendency for certain things to collect where conditions suit them. Some of Titan's lakes are small, some are large. Some have shorelines that curve gently. Some have shapes that look like puzzle pieces, suggesting they filled and retreated and filled again over time. And you might wonder, how can we know what these shorelines look like if Titan is wrapped in haze? This is where a different kind of seeing becomes important. When you cannot see through fog with your eyes, you might use a flashlight, or you might listen for echoes, or you might feel your way carefully. Spacecraft do something similar. They use instruments that do not rely only on visible light. One of those tools is radar. Radar is a kind of signal that bounces back. It is like sending out a gentle call and listening for the reply. Different surfaces reflect radar differently. Smooth liquids can reflect in a way that looks dark in radar maps, because the signal bounces away rather than back to the receiver. Rough land reflects more signal back and can look brighter. So even through haze, radar can help outline lakes and shorelines. It can sketch the shape of the surface in a calm, indirect way, like drawing a landscape by feeling it with a soft glove. This is why we can speak about Titan's lakes with confidence, without needing to imagine perfect photographs. Science, at its best, is often like that. Not a loud certainty, more like a careful lantern, a tool that widens the darkness gently without rushing. As you rest, you can let your mind hold a simple set of images. Titan is wrapped in a thick, hazy atmosphere. Tiny particles float high above, born from slow chemical reactions in the sky. Those particles scatter the sunlight and tint the world orange. The surface below is cold enough that water becomes hard like rock. In that cold, methane and ethane can become liquid. They gather into lakes, especially near the poles, where conditions favour their quiet pooling. That is already a complete picture, even if we stop here. But we won't stop. We will keep moving slowly, like walking along that shoreline under the orange sky, looking closer and closer at the gentle chemistry that makes it all possible. If you are still awake, you can stay with me. If you are drifting, you can drift. Either way, the story continues like a calm river. Now let's return to the sky for a moment, because it is the sky that sets the mood of Titan, and the chemistry in the sky is the first step in understanding the chemistry on the ground. High above Titan's surface, methane and nitrogen float in layers of air. When sunlight reaches those layers, it carries energy. Even though Titan is far from the sun, the light that arrives can still do quiet work. It can break apart some molecules. This breaking is not violent in the way we imagine breaking. It is more like snapping apart tiny pieces that can then rearrange. Once the pieces rearrange, the atmosphere begins to produce more complex molecules, and those molecules can eventually form haze particles. Over time, some of these particles drift downward, slowly, like dust settling in a quiet room, and when they settle, they become part of the surface materials, adding to dunes and dark patches. This is one of Titan's hidden patterns. The sky makes particles. The particles tint the sky. The particles also fall and become part of the ground. The ground shapes the way liquids move and pool. Liquids evaporate and return to the air. The air feeds the sky chemistry again. It is a loop, a soft loop, a cycle. A cycle simply means something that repeats in a gentle circle. Not identical every time, but similar enough to recognize. On Earth, water cycles through evaporation, clouds, rain, rivers, and oceans. On Titan, methane and ethane can do a similar dance. And when you hear that, you might feel the calm satisfaction of pattern recognition. The universe has themes. It plays them in different keys. Titan is one of those variations. If you want a bedtime-friendly analogy, imagine a familiar song played on a slow piano. Then the same song played on a low cello. The notes are similar. The feeling changes. Titan is the cello version of some of Earth's patterns. Lower, slower, dimmer, and wrapped in haze. As you settle deeper into comfort, you can allow a little repetition, because repetition is one of the gentlest ways the brain relaxes. Titan's sky is orange because tiny particles float in the air and scatter the sunlight. Those particles are made by chemistry happening high above, where methane and nitrogen are slowly transformed. Titan's lakes are real, but they are made of methane and ethane, liquids that exist because of the cold. Titan's atmosphere is thick like a blanket, and it helps keep the surface stable and quiet. Each of those lines is like a small smooth stone you can hold. You do not need to juggle them. You can just let them rest. Now, as we continue, we can stay close to the surface and to the feeling of that Titan shoreline. Imagine standing near the edge of one of Titan's lakes. The air is hazy, the sky is amber, the light is dim but not empty. It has a presence. The lake is dark and still, like oil, but not oily in a messy way. Just dark, smooth, and reflective. You can picture the shoreline as gentle curves, with ground that might be made of water ice as hard as rock, mixed with grains of organic material, which simply means carbon-based grains. Some areas might feel like sand dunes shaped by wind. Wind exists on Titan too, and it can move grains and create ripples in dunes just as it does in deserts on Earth. When you see that image, you can feel something reassuring. Titan is not a chaotic place. It is not a place of sharp danger. It is a place of slow shaping. Wind, haze, shorelines, time. Time is one of Titan's main characters. On Titan, changes happen in long rhythms. The weather can be seasonal. Rain can be rare in some places and more common in others. Lakes can fill and shrink over long periods. Haze can thicken and thin. Dunes can migrate slowly, grain by grain. Nothing about this needs urgency, and that makes Titan a perfect bedtime topic. It is science that naturally speaks the language of patience. Now, let's gently prepare to go one step deeper next, without forcing it tonight. Soon we will talk more about Titan's methane weather, the way methane can evaporate, form clouds, and fall as rain. We will keep it calm and simple, like describing a slow breath of the atmosphere. And we will also talk about Titan's surface chemistry, the way organic materials settle and the way even in deep cold, reactions can still happen quietly. But for now, as we close this section of our journey, you can let yourself sink a little more into your bed. If you notice any tension left in your body, you do not have to chase it. Just notice it and imagine it loosening on its own schedule, like a knot in a ribbon slowly untying itself without hands. Your breathing can remain easy, your mind can remain lightly curious, and the image can remain. An orange sky, a quiet lake, and the gentle chemistry linking them, like a thread you can follow at any speed you want. In a moment, we'll keep walking along Titan's shoreline and begin to feel the rhythm of its weather and the slow loops that move liquid from surface to sky and back again. And if sleep comes first, that is perfectly fine. The orange sky can keep glowing in the distance, and the dark lake can keep reflecting it, and your mind can rest inside that calm, unhurried world. If you're still awake, you can let your attention return in the easiest way, and if you've drifted a little, you can simply arrive back without catching up. Nothing important is going to rush past you. We're still on that quiet shoreline, under the soft orange sky, with the dark lake resting like glass. A good way to keep going is to look at one small piece at a time, the way you might study a single candle flame without thinking about the whole room. On Titan, one of the smallest pieces that changes everything is the way light moves through air. On Earth, light often feels clean and direct. You step outside, and the world shows itself in bright detail. On Titan, light is more like a whisper. It arrives from far away, and then it meets haze, and then it spreads. The orange sky is not just a colour. It is evidence that the air is full of tiny things, floating, drifting, and quietly interacting with sunlight. You can think of Titan's haze as a kind of soft curtain, and the curtain is made of countless particles, Each one extremely small, each one a little result of chemistry. Chemistry, in the simplest sense, is the way matter changes its partnerships. Tiny pieces join and separate. They build new shapes. They become new substances. On Titan, chemistry happens in the upper atmosphere because energy arrives there first. Sunlight, even weak sunlight, carries enough energy to nudge molecules apart and invite them to recombine. And when molecules recombine, they can form new carbon-based molecules. Carbon-based means built around carbon, a very flexible building block. Carbon can make long chains and rings and branching shapes. This is why carbon chemistry can become complex without needing anything dramatic. It is like a set of small wooden pieces that can be connected in many different ways. So high above Titan's surface, methane molecules can be broken and reassembled. Nitrogen can also take part in these reactions. Over time, the atmosphere produces a kind of chemical smog, not in a dirty city way, but in a gentle cosmic way. A soft haze made of tiny particles. When scientists talk about those particles, they may call them aerosols, which simply means tiny floating particles suspended in air. Titan's aerosols are special because they are not just dust from the ground. They are manufactured by the sky. That sky-made haze does a few quiet jobs at once. One job is to scatter light. Scattering means light bounces off tiny particles and changes direction. When light scatters, it becomes less direct and more spread out. Edges soften, shadows blur. The whole world looks as if it is lit through a thin veil. Another job is to absorb some light. Absorb means the particles take in certain colours more than others. When some colours are taken away and others remain, the overall look shifts. On Titan, the balance of scattering and absorbing tends to leave the world tinted warm, with that famous orange tone. And another job is to help shape temperature, not in a harsh way, but like a gentle thermostat. Some sunlight is reflected before it can warm the ground. Some heat is held in by the thick air. The atmosphere and haze together create a steady environment, a kind of soft climate chamber. If you want to keep it very simple, you can hold this idea. Titan's haze is like a blanket and a lampshade at the same time. A blanket because it helps hold heat in, a lampshade because it filters and softens the sunlight. Now, let your mind rest on something quiet and familiar. Think of a lamp in your room. If you put a shade over it, the light becomes warmer and gentler. The shade does not create light. It only changes how the light arrives. Titan's haze does something similar. It changes the mood of the sunlight. And it does it all day, every day, because the haze is always there, floating in layers. This is part of the comforting mystery of Titan. Even though it is cold, its light feels warm. Even though it is far away, its sky can feel like evening at home. If your mind likes to wander into a soft question, you can ask it quietly. What does it feel like to live under a permanent sunset? And you do not have to answer. You can just let the question drift like a feather. Now we can let the sky lead us down toward the surface, because the haze does not stay only in the sky forever. Over time, some particles settle, very slowly, like dust in still air. They descend and become part of Titan's surface materials. This is another gentle pattern that links sky and ground. The sky makes particles. The particles tint the sky. The particles fall to the ground. The ground becomes coated with a thin layer of complex carbon chemistry. And then, on that ground, liquids can move, collecting and shaping the land. So when you look at Titan's lakes, you're not only looking at liquid, you're also looking at the result of a long exchange between atmosphere and surface. Now let's return to the lakes and take them seriously in a quiet way. A lake is one of the calmest forms of motion. It is stillness that is held in place by gravity. Gravity, which simply means the pull that gathers things downward, gathers liquids into low areas. On Titan, gravity is gentler than Earth's, but it still does the same job. It encourages pooling. It invites a surface to settle. The surprise, as you already know, is that Titan's lakes are not water. They are mostly methane and ethane. Methane is a small molecule made of carbon and hydrogen. Ethane is similar but slightly larger. On Earth, these are gases at everyday temperature. They drift invisibly in air unless they are compressed or cooled. On Titan, the cold is deep enough that these molecules slow down, cling together, and become liquid. A simple way to picture this is to imagine people in a room. When everyone is moving fast, they bump and swirl and separate. It's hard to hold hands. That's like a gas. When movement slows, it becomes easier for people to stay close, to cluster, to form groups. That's like a liquid. Cold slows molecular motion. So Titan's cold makes it easier for methane and ethane molecules to stay together as a liquid. This is not magic. It is just the same physics you already know, expressed at a different temperature. Now you might ask another gentle question. If methane can be a liquid, can it also have weather? Yes, and this is where Titan becomes both familiar and dreamlike. Titan likely has a cycle that resembles Earth's water cycle. On Earth, water evaporates, forms clouds, falls as rain, and returns to lakes and oceans. On Titan, methane can do a similar loop. Evaporation simply means a liquid turns into gas and rises into the air. It happens when some molecules at the surface have enough energy to escape. On Titan, methane can evaporate from lakes, especially when seasons and sunlight make conditions right. Those methane molecules can then rise and cool, and they can gather into clouds. Clouds are simply collections of tiny droplets or crystals suspended in air. On Earth, clouds are water droplets and ice crystals. On Titan, clouds can be methane droplets, under the right conditions. And then, in some places and times, methane can fall as rain. Not constantly, not everywhere. Titan's weather is slow and seasonal. It can be quiet for long periods, then active for a while, then quiet again. Like a long inhale of the atmosphere followed by a slow exhale. If you find the idea of methane rain strange, let it stay gentle. Imagine rain that falls softly, not stormy. Imagine it darkening the ground and feeding channels that lead back to lakes. Imagine the sound as muted by thick air and haze, more like a hush than a drum. Now we can ground this in the landscape. Titan's lakes tend to gather near the poles, where it is cooler and where the climate seems to encourage long-term pooling. In radar maps, these lakes appear as smooth, dark patches, because calm liquid reflects radar in a way that sends much of the signal away. The shorelines can appear crisp, like boundaries between smooth liquid and rougher land. In some areas, there are shapes that look like river channels leading into lakes. That suggests a history of flow, of liquid moving over the surface and carving gentle paths. Carving does not have to mean violence. Carving can be slow, like a stream shaping a stone over years, like wind smoothing a dune grain by grain. On Titan, time is a sculptor that works patiently. As you listen, you can let yourself rest inside this slow sculpture. A lake fills, a lake shrinks, a shoreline moves, a channel deepens a little, a dune shifts. Haze continues to fall in tiny grains. Everything changes, but nothing changes quickly. Now, because Titan is wrapped in haze, the way we study these features has a special calmness to it. We cannot simply look with normal eyes and see a bright, clear landscape. We have to use other forms of sensing. Think of being in a foggy night on Earth. If you walk carefully, Your eyes are not your only guide. You listen. You feel the air. You notice echoes. You might use a light that works differently, or you might move slowly until shapes reveal themselves. Spacecraft do something similar with radar. Radar sends out a signal and listens for what returns. When the signal bounces off a surface, the return tells you something about that surface. Smooth surfaces behave differently than rough ones. Liquids often appear smooth. Rough terrain appears textured, so radar becomes a way to see through the haze. Not by removing the haze, but by choosing a kind of signal that can pass through it more easily. And there is something soothing about that approach. Instead of fighting the haze, science works with it. It chooses a different sense. It adjusts. It listens. You can imagine the spacecraft as a patient listener, sending out gentle pulses and receiving quiet replies. This is why I like to think of science here as a soft lantern, not a spotlight. A lantern does not turn night into noon. It simply makes enough room to walk safely and to notice small details. Now let's bring your attention back to one of the most comforting contrasts in this story. Titan is extremely cold, yet it looks warm. It is far away, yet it feels familiar. It has lakes, but not water lakes. It has clouds and rain, but with methane. It is not Earth, and yet it rhymes with Earth. That rhyme is one of the hidden patterns we're following tonight. Nature repeats shapes and cycles, but it changes the ingredients based on the environment. If water is not free to flow because it is frozen like rock, another substance may take over the job. If sunlight is dim, haze may become the main painter of the sky. If the air is thick, weather may slow down and soften. The theme is steadiness. And if you're lying in bed, listening, you can let that steadiness become part of your own nervous system. A reminder that the universe can be gentle, even when it is strange. Now, we can move one step toward the surface itself, toward what Titan's ground might be made of, because the ground matters. It shapes where lakes can sit, how rivers can form, and how dunes can rise. On Titan, water is frozen hard, so the bedrock in many places may be water ice behaving like stone. That is a simple concept that can feel surprising at first, but then it becomes very calming. It means Titan's rocks are sometimes made of the same substance that makes our oceans, but locked into solidity by cold. On top of that icy rock there can be layers of organic material. Organic, again, simply means carbon-based molecules. It does not mean living. It means molecules built around carbon, often created in the atmosphere, and then delivered to the ground as haze particles settle. Over time, these particles can form grains. Those grains can behave like sand. Winds can move them. Dunes can form. So Titan can have dune fields, shaped by wind, made of carbon-based grains, resting on water ice rock. If that image feels too complex, you can simplify it into a bedtime version. A hard, cold ground, a soft, dusty layer, wind shaping it gently, lakes collecting where the land dips, and above it all the orange haze continually made by the sky. Now, there is one more gentle twist that can deepen the story without making it heavy. Even in the cold, chemistry still happens. We often associate chemistry with warmth, with bubbling and reacting. But chemistry can also be slow. It can happen in tiny steps. It can be like a clock that ticks once in a long while. Cold does slow reactions, but it does not erase them. Some reactions on Titan may be encouraged by sunlight high above, where energy is available. Some may be encouraged by energetic particles from Saturn's environment. Some may happen when liquids interact with surface materials, dissolving small amounts, carrying molecules, depositing them elsewhere. This is a quiet world where chemistry is not a flash, it is a drift. And drift is a good word for bedtime. Let that word settle. Drift. The haze drifts. The particles drift downward. The liquids drift along channels. The winds drift over dunes. Time drifts through seasons. And your thoughts can drift too. If you notice yourself getting sleepy, that is exactly right. You do not need to hold on tightly. The information is designed to repeat softly, to come back in slightly different words, to keep you afloat even if you miss a sentence here and there. So let's repeat the core picture again, with small changes. Titan's orange sky is made by haze, tiny particles floating high above, created by slow chemistry in the atmosphere. Titan's lakes are made of methane and ethane, liquids that exist because the world is so cold. Water on Titan is mostly frozen, acting like rock, shaping the ground beneath. The atmosphere is thick, a blanket of air that helps stabilize the surface and filter sunlight. Radar and other instruments let us map the surface through the haze, like listening to echoes in fog. If you can hold those ideas, you have the whole foundation. Now we can take a gentle step forward into Titan's weather, because weather is the bridge between sky and lake. Weather is the way liquids and gases trade places. Weather is the rhythm that moves material around without anyone pushing it. On Earth, the water cycle is a familiar loop. The sun warms water. Water evaporates. It becomes vapor, which is water as a gas. The vapor rises and cools. It forms clouds. Clouds release rain. Rain runs into rivers and lakes, and the loop continues. On Titan, the sun is weaker, but the loop can still exist with methane. Methane can evaporate from lakes. It can become methane vapor in the air. That vapor can rise and cool. It can form clouds. Those clouds can release rain, returning methane to the surface. This is like Earth's water cycle, but translated into Titan's chemistry and temperature. And what does that feel like? Emotionally, it feels like reassurance, because it means Titan is not dead still. It is active, but in a gentle way. It is alive with motion, but slow motion, like a slow-moving dream. When methane rain falls, it can create wet patches and feed channels. When the rain stops, the ground can dry as methane evaporates again. Lakes can rise and fall. Shorelines can shift, not quickly, quietly. And because Titan has seasons, the pattern can change over long times. A season on Titan is not like a quick flip of weather. It is a long, gradual drift of conditions. So the world can have periods of more cloud activity and periods of less. If you like, you can imagine Titan's weather like a slow breathing pattern. Inhale, evaporation, vapor rising, pause, clouds gathering, exhale, rain returning, pause, lake settling again, and then the cycle repeats. Now, as we come toward the end of this segment of our journey, we can keep the tone very gentle and prepare to go even deeper next. Next, we can look more closely at how Titan's methane weather shapes the surface, how rivers and channels form, and how the landscape tells a story of liquid movement. We can also explore more of Titan's surface chemistry, the dunes and organic sands, and the way sky-made molecules become ground-made textures. But for now, let's let the mind rest in the simplest version of Titan again. A still lake, a soft orange sky, a thick, hazy air, a slow weather cycle that moves liquid to sky and back again, and beneath it all, a patient chemistry, working so slowly it feels like time itself is doing the mixing. If you're still awake, you can stay with that. If you're getting sleepier, you can let the words become like distant waves. Either way, you're safe. There is no need to remember everything. You can simply float beside Titan's quiet shore, watching the orange light hover in the haze, and listening to the gentle idea that even far from home, nature can be steady, patterned, and calm if you're still awake. You can let your mind settle back into the scene as if you're returning to a warm room after stepping out into a cool hallway. And if you've fallen a little asleep and come back, that's fine too. The story is still here, moving slowly, like a steady lantern glow that doesn't flicker much. We're still near that dark lake under the orange haze, and now we can let the lake teach us something about weather. Because on Titan, the lake's not only places where liquid rests, they're also places where liquid can leave, invisibly, molecule by molecule rising into the air. On Earth, you already know this feeling, even if you don't often name it. A puddle disappears after a warm day, a wet towel dries on a line, steam rises from a mug and becomes part of the room. That change from liquid to gas is called evaporation, which simply means some molecules at the surface slip free and drift upward into the air. Evaporation is not loud, it is not dramatic, it is not an event you can point at and say, there it is. It is a quiet thinning, a soft vanishing, a slow trade, where a lake gives a little of itself to the sky. Titan's lakes can do the same, but with methane and ethane instead of water. The conditions are different, the temperature's different, but the basic idea is still familiar. If a molecule has enough energy to break away from the surface, it can rise into the air as a gas. Now Titan is cold, so you might wonder, where would that energy come from? Some of it comes from the faint sunlight, some comes from the gentle movement of air, some comes from the way seasons shift the balance over long time, and some comes from the simple fact that even in cold places molecules still move. They just move more slowly. They're still tiny variations, still a little restless motion. So methane can evaporate from a lake on Titan, slowly, steadily, and then the methane vapor can mix into the atmosphere, that thick blanket of air wrapped around the moon. Once methane is in the air as a gas, it can travel, it can drift on winds, it can rise and cool, and when it cools enough, it can condense. Condense simply means the opposite of evaporation. It means gas turns back into liquid, becoming tiny droplets. Those droplets can gather into clouds, so Titan can have clouds made of methane droplets, under the right conditions. If you let yourself imagine those clouds, keep them gentle, not towering thunderclouds, not sharp lightning, just soft layers like smudges in the haze, drifting across an orange-tinted sky. The clouds might be hard to see in visible light because Titan's haze already makes the sky dim and diffuse. But the clouds are there as part of the methane cycle, moving in slow loops. And then, sometimes, those clouds can release methane rain. It's worth pausing here, because this is one of the quiet contradictions that can make Titan feel so dreamlike. Rain without water. But the feeling of rain can remain familiar even if the chemistry changes. Rain is simply liquid falling from the sky, returning to the surface. It is gravity doing its gentle work, pulling droplets down. On Earth, rain fills puddles and feeds rivers and darkens soil. On Titan, methane rain can darken the surface too, and it can feed channels, and it can return liquid to lakes. You can picture methane rain as a soft patter that is muted by the thick air, more like a hush than a sound. You can picture droplets falling through orange haze, catching faint light, and vanishing into the darkness of the ground. It doesn't need to be intense. It can be sparse. It can be seasonal. It can be the kind of rain that happens after a long, quiet build-up, then fades again. Titan's weather likely has long pauses. A lot of Titan is patience, and that patience is one reason this topic fits so well with bedtime. Because nothing here insists that you stay alert. This story itself encourages slowing down. Now, if methane rain falls, what does it do on the ground? Over time it can carve. Carve is a strong word, but the action can be gentle. Imagine a very slow stream on Earth, not a flood, just a thin ribbon of water that moves again and again. It nudges sand, it carries little sediment, it smooths a path, it deepens a channel one tiny bit at a time. That is carving. On Titan, methane can flow across the surface when it rains. It can gather in low places and move downhill. It can form channels that from far above resemble river valleys on Earth. The chemistry is different, but the shape of flowing liquid is familiar. This is another pattern that repeats in the universe. Flow makes lines. Gravity guides them. Time deepens them. Liquid seeks the lowest places. It collects. It pools. It rests. You can imagine Titan's landscape as a quiet map drawn by liquids. Lakes at the poles, where conditions favour long-term storage. Channels leading toward those lakes, suggesting past or present flow. Plains shaped by wind and dunes, showing slow atmospheric motion. And above it all, haze that continues to fall like dust, feeding the surface with new carbon-rich material. If you want to hold this as a sleepy mantra, you can. Sky to ground, ground to lake, lake to sky. A loop that repeats. Now, we can talk about seasons without turning it into a calendar lesson. A season simply means the environment changes slowly over time because the amount of sunlight and the angle of sunlight change. On Earth, seasons can change weather patterns. On Titan, seasons can do the same, but more slowly and more subtly. Some seasons may encourage more methane to evaporate. Some may encourage more clouds. Some may encourage rain in certain regions. And over time, that could make lakes rise and fall, shorelines creep inward and outward, and the landscape tell a quiet story of shifting balance. If you picture Titan's lakes breathing, rising a little, falling a little, over long stretches, you are close to the truth of the feeling, and that breathing connects to your own breathing, which is doing its steady work right now, without asking you to manage it. If you want, you can let your breath be slow and easy, and let Titan's weather become a distant companion to that rhythm. Now we can step from the methane cycle into the surface chemistry, because the surface is where sky-made particles land, where liquids flow, and where time builds textures. On Titan, one of the most peaceful ideas is that water ice can be rock. This is not because Titan's water is special. It's because Titan is cold enough that water stays frozen hard. On Earth, when you think of ice, you might think of something temporary, something that melts, something that cracks, something that disappears with warmth. On Titan, ice can be stable like stone. It can form the ground itself. So when you imagine Titan's surface, you can imagine a foundation of water ice, tough and enduring, like bedrock. On top of that foundation, Titan has layers and grains made of carbon-based material. These carbon-based grains are often described as organic, which simply means they are built from carbon, not that they are alive. Some of these molecules begin in the atmosphere, formed by that high-altitude chemistry where methane and nitrogen are rearranged. The resulting complex molecules clump into haze particles. Those particles drift downward. They settle on the ground. Over time, they can build up like dust. Imagine dust settling on a quiet shelf. A layer grows so slowly you do not notice it day to day, but after months it is visible. Titan's haze can do something similar, except on a planetary scale. A slow fall of particles that gradually coats the world. Once those particles are on the ground, they can become part of dunes and dark plains. Titan has dune fields that look, in broad shape, like deserts on Earth. The dunes suggest winds that move grains, pushing them into ripples and ridges. Wind on Titan may not feel like wind on Earth. The thick air changes how wind behaves. It can make movement feel softer. And because Titan's gravity is lower, grains can be lifted and moved a little differently. But the overall idea remains familiar. Air moves. Grains respond. Dunes form. Dunes are like frozen waves of sand. They are a record of wind's long, repetitive motion. So on Titan, you can imagine dunes made of carbon-based grains, shaped by steady winds, resting on water ice ground under an orange sky. It is a strange combination, and yet it feels strangely coherent. Everything fits the environment. Now a gentle question arises. If Titan's surface is coated with carbon-based grains and haze materials, and if liquids like methane can flow across it, do the liquids interact with the surface chemistry? They can. Liquids can dissolve certain molecules, which simply means they can pick them up into solution, like sugar dissolving into tea. A liquid is not only something that flows, it is also something that carries. It can carry dissolved chemicals from one place to another. It can deposit them somewhere else when conditions change. So methane and ethane liquids on Titan may act as slow chemical transporters. They may pick up some molecules. They may carry them along channels. They may leave them behind at lake edges. They may concentrate them in certain places. This kind of chemistry is not a fast reaction. It is more like sorting. Like the way a tide carries shells and leaves them in a line when it retreats. The ocean doesn't need to decide where to place shells, it simply follows physics. Titan's liquids can do similar sorting over time. This is where Titan's chemistry becomes almost like a quiet craft, not a dramatic experiment, more like weaving. The atmosphere weaves molecules into particles. The particles drift down and become grains. The wind arranges grains into dunes. The liquids flow and redistribute chemicals, and the whole world slowly becomes patterned. There is something deeply calming in that. It tells you that complexity does not always require stress or speed. Complexity can arrive by patience. Now you might hear another term in Titan discussions, prebiotic chemistry. Prebiotic simply means chemistry that can come before life, chemistry that could be part of the steps that, in some environments, might lead toward living systems. But on Titan, we do not need to make this into a dramatic question. It is enough to say that Titan is interesting because it has a lot of carbon chemistry, stable liquids, and a long time for slow processes. Scientists pay attention to Titan because it is like a laboratory, where certain chemical stories can unfold in a different way than on Earth. But you, listening in bed, do not have to carry the weight of that. You can hold it lightly, like a small, smooth idea. Titan is a place where chemistry has time. Now, as we go deeper, it helps to remember that Titan's chemistry is not just on the surface or just in the atmosphere, it is connected. The same haze that colours the sky is also the source of many surface materials. The same methane that forms lakes is also part of atmospheric chemistry and weather. The same slow cycles that shape Titan's landscape also shape Titan's appearance. Sky and ground are in conversation. If you want, you can personify Titan's world a little, in a gentle way. The sky makes a quiet veil. The veil paints the light. The light touches the lakes. The lakes breathe methane into the air. The air gathers clouds. The clouds return the methane to the ground, and the ground waits patient under the steady fall of haze. Now, let's bring in the last major chapter of this section, the way we see Titan through its haze, because the method itself is calming. It is easy to imagine that space exploration is all about sharp images and sudden reveals, but Titan teaches the opposite. Titan teaches that sometimes you have to learn a world by listening, by measuring, by feeling with instruments that sense beyond normal sight. Because Titan's haze blocks much of the visible surface, spacecraft used radar to map it. Radar, as we said, is a signal that bounces and returns. You can imagine it like calling into the fog and hearing echoes. A smooth lake sends the signal away, like a mirror reflecting light in a single direction. That makes the lake look dark in radar data. A rough surface scatters the signal back in many directions, so some returns, and that makes land look brighter and textured. By comparing these patterns, scientists can outline lakes and dunes and mountains even without a clear photograph. This is almost like reading a story in Braille, not with fingers, but with signals. The landscape speaks back through the way it reflects and scatters. And there were also moments when a probe descended through Titan's atmosphere, drifting like a seed on wind and measuring the air as it went. It felt the density. It sampled the chemistry. It recorded the change in pressure. It sensed the world from within. That descent is another image you can keep if you like. A small visitor falling slowly through orange haze, listening to the atmosphere, gathering quiet facts, and then touching down gently like a feather settling. No rush, no crash, just a careful arrival. Now, here is a comforting thought that connects the science to your own life. Even when you cannot see something clearly, you can still know it is there. You know the shape of your room in the dark. You know the presence of familiar objects without staring at them. You know the sound of quiet, the way it changes when a window's open. You know the feel of your blanket without looking. Titan teaches the same lesson. When sight is limited, other senses and tools become more important, and knowledge becomes a gentle accumulation rather than a sudden spotlight. If your mind ever feels anxious about not having everything clear, Titan offers a soft metaphor. You can still navigate. You can still learn. You can still find the shoreline even in haze by listening for echoes and trusting slow patterns. Now, let's pause and repeat the core ideas again, because repetition is one of the most sleep-friendly forms of understanding. Titan's sky looks orange because tiny particles float in the air and scatter sunlight. Those particles are made by chemistry high in the atmosphere, where methane and nitrogen are slowly transformed. Some of those particles settle to the ground, creating carbon-rich grains. Titan's lakes are made of methane and ethane, liquids that exist because Titan is cold. Methane can evaporate, form clouds, and fall as rain, creating a slow weather cycle. Water on Titan is mostly frozen, acting like rock, shaping the land beneath. Radar and careful measurements help us map Titan's surface through its haze. If you've held onto those, you've done enough. If you've lost track, that's fine too. You can simply return to the image. Orange haze overhead, dark lake below, a quiet world breathing in slow loops. Now, as we continue from here, we can begin to connect Titan's chemistry to something closer to home, not to make it dramatic, but to make it comforting. Titan and Earth share patterns, not because they are the same place, but because the universe uses the same basic rules again and again. Temperature changes what can flow, gravity gathers liquids, light interacts with particles, cycles repeat. And when you notice those patterns, you may feel a kind of calm recognition. The universe is not random noise, it is structured, even when it is mysterious. That can be reassuring at night when the mind sometimes wants to invent fears or uncertainties. Titan offers a quieter kind of mystery, one that has structure and that invites curiosity instead of worry. So tonight you can let your curiosity be gentle. You can let your body be heavy. You can let your breath be easy. And you can let Titan remain in the distance, like a dim orange lantern in the dark, quietly showing you that chemistry can be slow. Skies can be painted by tiny particles, and lakes can exist in forms you might not expect without the world ever needing to hurry. In a moment, we'll move even further into the softer connections, the way Titan's chemistry can be described as a kind of weather for molecules, and the way that idea can settle your thoughts, the way warm light settles in a room. And if sleep arrives before we get there, that is perfectly fine. The story will keep flowing in the background like a calm tide while you rest. If you're still awake, you can come back gently, like returning to the surface of a quiet lake after dipping your hand into it. And if you're only half awake, that's even better. This is the kind of topic that does not mind being listened to through a soft fog of sleep. Now that we've met Titan's orange skies, its strange lakes, and its slow methane weather, we can let the ideas connect in a way that feels comforting rather than complex. Because the deeper truth underneath all of this is not complicated. It's simply that nature repeats patterns. A cycle is a pattern that returns. A haze is a pattern of tiny particles floating and drifting. A shoreline is a pattern drawn by liquids meeting land. A dune is a pattern drawn by wind meeting grains. And Titan is a place where those patterns are slow enough to feel almost like breathing. When you think of chemistry, you might imagine a lab bench, glass containers, and quick reactions. But chemistry can also be quiet. Chemistry can be the slow rearranging of molecules over long stretches of time. It can be more like weather than like a spark, and you can gently reframe it like this. Chemistry is weather for molecules. It is the way tiny building blocks move, meet, separate, and form new shapes. Sometimes the weather is active, like a storm. Sometimes it is calm, like a clear night. On Titan, the chemical weather is mostly calm but always continuing. Up high in the atmosphere, sunlight and energy nudge methane and nitrogen into new forms. That creates haze particles, which drift and scatter light, turning the sky orange. Those same particles slowly settle to the ground, contributing to the carbon-rich surface. On the ground, methane and ethane collect into lakes, and those lakes breathe methane into the air through evaporation. The air gathers methane into clouds. The clouds return methane as rain, and the surface quietly reshapes itself through flow, wind, and time. So Titan is not just a place with separate features, it is a connected system. Sky and ground are linked by slow exchange. If you like, you can imagine Titan as a gentle conversation. The sky says, "Here are new particles." The ground says, "I will hold them for a while." The lakes say, "I will borrow some of the sky's methane and keep it as liquid." The sky says, "I will take some back as vapor." The clouds say, "I will gather it and return it." And the whole cycle continues without any need for urgency. That kind of steadiness can feel very soothing at night, when the mind sometimes expects everything to be uncertain. Titan suggests that even far away, even in strange conditions, the universe can be consistent. It can be patient. It can keep its rhythms. Now, there is another comforting connection here, and it has to do with light. Titan's orange haze is not just a scientific fact. It's also a kind of emotional atmosphere. The world is dim. The light is filtered. The edges are soft. There is no harsh glare. If you've ever felt calmer in warm, low light than in bright white light, you already understand part of Titan's mood. Our nervous systems often relax when the world becomes gentler and less sharp. And Titan's sky is gentle by nature, because the haze does the softening. So when you imagine Titan, you're imagining a place that naturally matches the way bedtime feels. A dim room, a quiet horizon, a soft tint, a slow pace. You don't have to force yourself to relax. The imagery itself carries you there. And if you want, you can let your body sink a little more into whatever is supporting you right now. Let your forehead smooth, let your tongue rest, let your shoulders feel heavy, and let the idea of Titan's warm-coloured dusk settle over you like a light blanket. Now, we can also connect Titan to Earth in a way that stays simple. Earth has water that flows, Titan has methane that flows. Earth has clouds made of water droplets. Titan has clouds that can be made of methane droplets. Earth has rain that fills rivers and lakes. Titan has rain that can refill methane lakes and feed channels. Earth has dust and aerosols that colour sunsets. Titan has haze particles that colour the whole sky. Earth's chemistry and weather interact. Titan's chemistry and weather interact. So Titan is like a cousin world, not because it is the same, but because it shares the same basic language of nature, and that language is made of a few simple words: cold and warmth, light and shadow, liquid and gas, gravity pulling down, winds moving across, time repeating patterns. If you can hold those words, you can understand a lot about many worlds, and that can be calming too, because it means you don't need 1,000 details to feel grounded. You need only a few steady ideas that repeat. Now, there is something else Titan offers, and it's the feeling of scale. If you take one tiny detail like a haze particle floating high above Titan, that particle is so small it could never matter on its own. It drifts, it scatters a little light, it falls. But when you have countless particles, layer after layer, they change the entire sky. They paint a world. That is a gentle lesson about scale. Tiny things can create big effects when they gather, not quickly, not dramatically, but steadily. And at night, when thoughts sometimes feel too big, it can be comforting to remember the opposite is also true. Big feelings can be made of many small thoughts. If you soften the small thoughts, the big feeling changes. You don't have to solve everything at once. You can shift one small thing, like loosening your jaw, or making your breath a little slower, or letting one thought pass without chasing it, and the whole inner sky can change its colour. Titan's chemistry can become a soft metaphor for your own mind, not because you have to analyse yourself, but because the idea is gentle. Small processes, repeated, create a mood, and moods can change slowly, like weather. Now, as we move forward, we can let the story become even softer and more repetitive. This is where the information becomes simpler on purpose, because this is the point where many listeners begin to drift more deeply into sleep. So we'll keep returning to the same images, letting them circle like calm waves. Imagine the orange haze again, not bright orange, but a dim amber glow. Imagine it filling the sky like a thin mist of light. Imagine the lake beneath it, dark and quiet, reflecting the haze as if the lake is holding a second sky. Imagine the air as thick and gentle, a soft blanket of atmosphere pressing lightly on the surface. Imagine the cold that turns water into rock, steady and still. Imagine methane and ethane as the liquids that can flow in that cold, gathering in low places, shaping shorelines slowly. Imagine methane evaporating from the lake in tiny invisible threads, rising into the air without effort. Imagine clouds gathering, soft and faint. Imagine rain returning, not harsh, not loud, just a gentle return of liquid to the ground. Imagine time stretching, making everything slow enough to feel peaceful. And while you imagine all of that, you can notice your own body doing something similar. Your breath rises, your breath falls, your chest lifts, your chest settles, your thoughts drift up, your thoughts drift down, and you are held safely by the steady gravity of your bed and the quiet room around you. If your mind wanders to the edges of the unknown, you can also let that feel comforting rather than unsettling. There are things we know about Titan, and there are things we still wonder. We know Titan has a thick atmosphere. We know it has haze that tints the sky. We know it has lakes and seas of methane and ethane. We know it has weather cycles that move methane around. And there are quiet questions too. How exactly do all the surface chemicals arrange themselves over time? What happens at the edges of lakes, where liquid meets solid, season after season? How do dunes and channels and shorelines change over long eras? These questions do not need urgent answers tonight. They can remain like distant stars, present but not demanding. It can be soothing to know that wonder is allowed to stay open. You don't have to close every loop in your mind before sleep. You can leave a few gentle mysteries uncompleted, like a book left open on a bedside table, waiting calmly for another day. Now we can begin to drift even more, and in the drift we simplify the language into small, steady refrains. Titan's sky is orange because tiny particles float in the air. Those particles are made by slow chemistry in the upper atmosphere. The haze softens the light, like a lampshade. The air is thick, like a blanket. The world is cold, so water is hard like rock. Methane can be liquid in the cold, and it forms lakes. Lakes can evaporate methane back into the air. The air can make clouds. Clouds can return methane as rain. The cycle repeats, softly, slowly, patiently, and you can repeat those ideas as many times as you like, or you can let them fade into the background like a distant fan or a soft wind outside. Now, if you want a final guided visualization to carry you further into sleep, we can walk along Titan's shoreline one more time. Imagine you are walking slowly, not cold, not uncomfortable, just quietly present. The ground beneath your feet is firm like stone. The air is hazy and the light is amber and dim. The lake is beside you, smooth and dark. Every so often a small ripple moves across it, and then it disappears. You pause and look up. The sky is not starry in the way you might expect because the haze hides much of the view. But the sky is still beautiful. It glows. It feels like an endless ceiling of warm dusk. You take another slow step. The shoreline curves. The lake stretches into the distance, and you can almost feel the chemistry happening, not as a lesson, but as a presence. Tiny particles drifting, light scattering, methane quietly evaporating, clouds slowly forming somewhere far away. A world continuing its gentle loops, whether anyone watches or not. And as you continue your slow walk, your own thoughts begin to thin. They become quieter, less detailed, more like shapes, more like soft colours, more like the orange haze itself. Now, we can begin the soft ending without any sharp edge. You don't need to remember Titan's details. You can simply remember the feeling. A warm-coloured sky, a still lake, a slow, steady cycle, a distant world that moves like a calm breath. If you're still awake, you can let these last lines be a gentle goodnight. And if you're already half asleep, you can let them pass through you like quiet air. May your mind feel softer. May your body feel safe and heavy. May your thoughts drift the way Titan's haze drifts, slowly settling, slowly quieting. And somewhere far away, under an orange sky, a dark lake keeps reflecting dim light, and the chemistry keeps moving in patient loops as you rest and as the night carries you onward. And we can stay with that image a little longer without needing to move on too quickly. If you're still awake, it's okay. You're not behind. You're simply here, listening, the way you might listen to distant rain that never asks you to do anything. And if you're already drifting, you can let these words be like a soft blanket pulled up a little higher, not to wake you, just to keep the edges of the night feeling gentle. Picture Titan again, not as a fact but as a mood, a dim amber sky that never becomes harsh, a haze that turns the distance into softness, a lake that holds stillness so well it feels like it has its own quiet gravity. And beneath the lake, beneath the haze, beneath the long, slow weather, there is chemistry. Not busy chemistry, not noisy chemistry, chemistry that behaves like time itself, steady and patient. On some nights, your own thoughts can feel like weather too. They gather, they shift, they pass through, and you don't always control them. You simply notice them and you let them move on. Titan offers a calming reminder that motion doesn't have to mean disturbance. Motion can be slow. Motion can be soft. Motion can be the kind that helps things settle. The haze moves, but it also smooths the light. The wind moves, but it also shapes dunes into repeating curves. The methane moves, but it also gathers into lakes and returns as rain. Everything moves, but in a way that keeps the world quiet. If it helps, you can imagine the chemistry on Titan as tiny footsteps you never hear. A methane molecule escapes the lake's surface and rises. A few more follow. They mix into the thick air, they drift upward and cool. A cloud begins, not as a big shape but as a whisper of droplets gathering, and somewhere later, perhaps much later, those droplets return, falling as a soft rain, returning the borrowed liquid to the ground. That is a complete loop, a calm loop, and the loop repeats. You can let that repetition feel like breathing. The lake releases, the sky gathers, the cloud returns, the lake rests again. Now, let's take one more slow walk along the shoreline, but even slower than before. Imagine you are moving at a pace where each step feels like a thought becoming quieter. The ground is firm beneath you. The air is thick but calm, almost comforting in its presence. The haze makes the horizon feel close and far at the same time. You look down at the edge where land meets lake. On Earth, the edge of a lake can be busy. Insects, reeds, waves, reflections changing quickly. On Titan, the edge feels quieter. The world is colder. The pace is slower. The lake is dark and still, and the shoreline is a gentle curve, as if it has had a very long time to find the smoothest shape. If you imagine the shoreline closely, you can picture how it might change over seasons. A little rain arrives after a long pause. The lake expands, almost imperceptibly. The edge moves outward. Then, over time, methane evaporates again, and the lake shrinks. The edge moves back, and in that slow back and forth, the shoreline becomes a memory of weather, a memory written in shape. This is one of the quietest ways nature keeps records, not in words, not in numbers, in form. A channel in the ground remembers flow. A dune remembers wind. A shoreline remembers the level of a lake. And the haze in the sky remembers chemistry. If you want another gentle metaphor, you can think of Titan as a place where everything is written in soft handwriting. No sharp lines, no frantic scribbles, just slow curves, repeating strokes, and steady loops. Now you can let your mind simplify everything into a few calm sentences, the kind you could almost hum. The sky is orange because tiny particles float. The light is soft because the haze scatters it. The world is cold, so water is hard like rock. Methane can be liquid, so lakes can exist. Lakes breathe methane into the air. The air can return methane as rain, and the cycle repeats, quietly. If you notice any part of your body still holding tension, you don't need to chase it down. Just choose one place gently and soften it as if you are turning down a dimmer switch. Maybe the muscles around your eyes, let them rest. Maybe your shoulders, let them feel supported. Maybe your hands, let them be heavy. And as your body loosens, your mind can loosen too, the way Titan's haze makes the light loosen into softness. Now, if your mind tries to pull you into something else, something from your day, you can return to Titan as a safe place to rest your attention, not because you're escaping reality, but because you're giving your nervous system a calmer picture to hold. A distant world with steady rules. A world that isn't asking you to solve anything. A world where even the surprises are gentle and can be understood slowly. A sky that stays in twilight. A lake that stays quiet. A chemistry that stays patient. And if you like, you can let the gentle unknown remain at the edges, like a soft border. We know Titan has these lakes. We know the haze paints the sky. We know methane moves in cycles, and there are still details that remain quietly unfinished, like the last lines of a poem you don't have to read tonight. How do the shorelines change over thousands of years? How do dunes migrate in the thick air? How do molecules arrange themselves at the edges where liquid meets solid? These questions can remain open without becoming stressful. Some mysteries are restful when they're held lightly. Now we can begin to thin the language even more, as if the words are becoming farther away. Orange sky, soft haze, dark lake, cold ground, slow wind, quiet cycles, and you can let those phrases drift through your mind the way a single cloud drifts through the evening, never in a hurry, never needing attention. Imagine the haze like a gentle veil over a lamp. Imagine the lamp's warm glow filling the room. Imagine the lake like a mirror laid flat. Imagine the mirror holding the glow. Imagine the air like a blanket. Imagine the blanket keeping everything soft. And in that softness, imagine your own breathing becoming the main sound, the main rhythm, the main anchor. In, out, in, out. Nothing else needs to happen. And if you're still listening, you can let the science become more like a lullaby than a lesson. Just a repeating pattern of nature doing what it does. Particles form, particles float, light scatters, sky glows, lakes gather, lakes breathe, clouds collect, rain returns, time continues, everything stays gentle. Now I'll leave you with the simplest image of all, a quiet shoreline on Titan under an orange sky, a dark, still lake reflecting that dim light, and a slow, patient chemistry moving through the air and across the surface, like a calm tide you can barely see. You don't need to follow it, you can simply rest beside it, and if sleep is close, you can let it arrive naturally. The way methane vapor rises from a lake without being forced, the way haze settles without being pushed, the way night deepens without anyone telling it to, just softly, just slowly, just as you are. You can let this be the quiet ending, with no sharp edge. If you're still awake, it's okay. And if you're already drifting, you don't need to come back for these words. They can pass by like a soft breeze, and you can keep resting exactly as you are. Hold the last image gently, as if you're holding a warm cup in both hands. An orange sky, dim and steady. A lake as dark as polished glass. A shoreline that curves without hurry. A world that moves in slow, patient loops. And in that faraway calm, nothing demands your attention. Nothing asks you to fix anything. The chemistry continues quietly, the haze continues drifting, the lake continues reflecting, and time continues smoothing everything into gentler shapes. You don't need to remember the details. You don't need to stay awake for understanding. You can simply rest with the feeling of it, a steady rhythm, a soft light, a safe, quiet night. And as the words thin out now, you can let the silence grow in the spaces between them. Let your breathing be easy. Let your body be heavy. Let your thoughts drift like haze, settling on their own. And somewhere, under Titan's orange skies, the dark lakes remain still, and the slow chemistry keeps its gentle pace while you sleep.